Okay, welcome back. So my name is Brian Madena, and today we are going to begin a new series of videos. And so, as I said, my name is Brian Madena, and I am the lead tutor in East Academia. So my YouTube channel is known as East Academia. So I'd like you to subscribe, share, and like the material if you find it helpful. So in this series of videos, I'm going to teach Calculus 1. And calculus 1 basically deals with differentiation. Okay, so this is the first introductory video when it comes to differentiation, and I want to tell people I want to introduce you to what exactly differentiation is. So what exactly is differentiation? So differentiation basically, in differentiation, what basically in differential mathematics looks at is how a certain quantity varies with respect to another. Okay, so differentiation usually have looking at how quantity y varies with respect to a certain quantity, say x. So y and x, these just represent quantities. So these are variables, okay? So y can be, let's say, distance, and x can be, say, time, okay? So y, x, you can also use, maybe some people can use for time, they can use t, and then for distance, some people can use just d, okay? But mostly, when it comes to differentiation, all variables, all quantities, mostly we usually use y and x. And I think you've learned algebra for you to have reached to this calculus 1 classroom. So the first thing is in differential calculus is we are looking how a certain quantity or a certain variable varies with respect to another quantity or with respect to another variable. Okay, so let us say when we are looking at how distance, so distance changes with respect, how distance changes with respect to, so just write WRT, to time, okay, t. So that means as time changes, okay, so this is a clock. So as time changes, so for example, you are traveling in a vehicle. This looks like that, so I'm not good at drawing, so I'll just have this. So assuming you're traveling in a vehicle, rather if you're driving or you're driven, but let's say you're inside a vehicle. So you realize if you're traveling, let's say from Nairobi, and you're going to Mombasa, I'll just say to Mombasa, okay, this is usually 500, approximately 500 kilometers. We'll just assume that way. So the truth of the fact is that as you move from Nairobi to Mombasa, time also changes, okay? Time also changes because you can leave Nairobi, let's say it's 9 a.m. And by the time you are arriving Mombasa, we say maybe it is 9 p.m. Okay, so what means is that as distance changes, because when you live here, let's say here you had covered 0 kilometers, and when you reach here you have covered 500 kilometers. Okay, 500 kilometers. So 0 kilometers 9 a.m. Okay, so I'll just have this 0 kilometers 9 a.m. and then you shall have finished 500 kilometers when it's 9 p.m. So these 500 kilometers, this person has covered them in how many hours? In 12 hours. So just say 12 hours here. So as you can see, the distance is reducing and the time also is changing, isn't it? So now differential calculus usually works the same way. Okay, what do I mean when I say differential calculus works in the same way? That in differentiation, we usually have two quantities. So quantity x, which can be distance, and then quantity y, which can be time. So either of these quantities can change with respect to another. Okay. So for example, if distance changes with respect to time, we are going to be talking about a quantity known as speed, isn't it? So this speed is usually the rate of change of distance with time. So speed is nothing but rate of change. So rate of change of distance with time. So sorry, I'm using abbreviations. For using abbreviations. So the rate of change. So basically what I'll say now, differentiation is, this is what defines differentiation. So differentiation basically will be looking at rate of change. So in differentiation, we shall be looking at the rate of change of a certain quantity with respect to another quantity. Okay, so basically differentiation will be looking at the rate of change of one quantity with respect to another quantity. So for calculus 1, we shall only be looking for two quantities. So we shall say maybe speed with respect to time. If it is if it is distance with respect to time, so just two quantities, so two variables, only x and y. And then when you go to when we go to higher differentials or higher degrees of differentiation, you can even have multiple quantities changing with respect to one variable. Like for example, when you're working in the industry, let me just give another example here. When you're working in the industry, so for instance, okay, let's say for instance you're working in the industry and you're having a machine, isn't it? And you're having a machine. So when you're working in the industry and you're having a machine, and suppose this machine is a motor, so I'll just say motor here. You realize that we could have several quantities changing here with time. Okay, so the first thing that could change with respect to time for this machine is the speed, isn't it? So I'll just say speed and denote it with S. The other quantity that can change with respect to time is also the heat or the temperature of this motor as it's rotates, isn't it? So you can have temperature, and I'll denote T. Okay, another thing that can change with respect to time in this temperature in this machine can be, say, let's just have this one. So this one is an example of a multivariable differential equation. So in when it comes to differential equations, or rather calculus, when it comes to calculus, we usually say this symbol f usually means something is a function of that. Okay, so if a certain quantity, like for here, whatever the variables you're having is speed and temperature, the ones that are changing, so I'll say my variables are a function of speed S and temperature T. Okay, but again, since we know that all these speed and temperature also vary with time, I can also just say that this is also a function of time. So I'll just so for time, I think now that I've already used T, I think for time I'll just have to use let me just say use capital T. So these are my variables. So I have speed, I have temperature, and I have time. But here we see that we have speed and temperature, all of them varying, all of them changing with respect to what? to time. So we can have two separate differential equations. If, for example, we want to see how speed changes with respect to time, like maybe if it's increasing or if the speed is reducing as time goes by, we can have a differential equation. Then we can also have a differential equation for temperature, whereby we're measuring the temperature of the machine as time goes by, or if it's increasing, if it's reducing. Right. Alternatively, we can have an equation, a differential equation that encompasses both. Okay, that encompasses both. So in this case, we are going to have a second order differential equation, which now is going to be written as second order differential equation, okay, which now can be the rate of change, okay, the change with respect to speed and the rate with respect to temp, okay, the change in speed, which is ds, and the change in temperature, which is dt, all of them varying with respect to time. Okay, so this is what now we call a second order differential equation. Second order differential equation, and that's why we have number 2 here. Okay, what this means is that we have quantities varying. Okay, we have quantities varying. We have two quantities that are varying with respect to one variable. Okay, and I will also say something here, because sometimes you might have the same quantity but now taking it twice. Like, for example, if you take speed, okay, now let me just, before I go into that, let's talk about the order of a differential equation. Order. So a differential equation is usually given in terms of d. So what d means, d usually represents a change in quantity. Okay, so d represents a change in quantity. And when you go too much into mathematics, you are going to realize that this d is usually initially not d, is usually represented as delta. Now this is capital delta, which is written as this way, and then the small delta is usually written as something of that kind, but we shall see later. I mean, these are Greek symbols and I'm not here to teach you Greek, so we shall see later how this how all this is written. So now let's say time is changing. So a change in time, in mathematics, we should represent a change in time as follows. So a change in time, so sorry, we said time is capital T, so only for this video because I use temperature. So a change in time would mean that this is time 2 minus time 1. Okay, so final time, let's say our vehicle here was coming from Nairobi. At what time? We had our vehicle somewhere here. So our vehicle here that was coming from Nairobi, it left Nairobi at 9 a.m. and reached at 9 p.m. So the change in time, which is delta t now, will be given as the final time, which is 9 p.m., the arrival time, which is 9 p.m., isn't it? So 9 p.m. minus 9 a.m., which of course we said it's 12 hours, isn't it? So the change in time, which is delta t, is 12 hours, isn't it? So delta t, we say this will now be 12 hours. Okay, and then now the distance has also changed, because the distance first, it had 0 kilometers. The vehicle had covered 0 kilometers, and then finally when it reaches to Mombasa, it had covered 500 kilometers, isn't it? So what is the change in d? Change in d will be d2 minus d1, final minus initial. That's always the rule. Okay, final minus initial. So which will be 500 kilometers minus 0, which will be 500 kilometers, isn't it? 500 kilometers. So then if we have that, because now if we have the change in distance, so delta d, divided by the change in time, delta t, which now this will be 500 over 500 kilometers over 12 hours. Okay, what is this going to give us? Now here I'll have to incorporate my calculator. So I will look for calculator here. So let me just look for calculator. No, let me just use the normal calculator, the one that most people use. So fx 820 82, yeah. So again, so we said that it's we had covered 500 kilometers in 12 hours. So does this give us 125 over 3? But what is that? 41 point, let's say 67. I'll just round off to 2 decimal places. So it's 41.67. So this is 41.67 kilometers per hour. So this is a rate of change of now this 41.67 is now the rate of change of speed with respect to time. No, of distance with respect to time, okay? So this is the rate of change of distance with respect to time. So the distance is changing at a rate of 41.67 for every hour. That means after 1 hour, whoever is traveling that bus, it could be you, it could be whoever, or me, will have covered 41.67 kilometers. So now this rate of change gets a new name, isn't it? It's no longer called change of speed, what, no. Because of that, usually give it another different name, which in this case we shall call it S. Now it becomes speed. So the rate of change of distance with respect to time is known as speed. Now in calculus, we don't write these deltas, okay? What we do, we usually write them, as I said, we usually represent these things with a capital D, okay, small d, and then as I said here, because this is distance, you shall respect it with the y, we shall represent distance with y, and then time we shall represent it with x, because as I said, usually use x and y variables as quantities, okay? So now my dy dx, now which represents the where y represents, okay, y represents, I said y represents a distance, and then x represents time. So don't confuse. I mean, you can have whatever quantity. Other people even use other Greek symbols, including, you can have differential equations which are written even this way. Let me just show you. I've come across several differential equations, so I know. So you can have differential equations which are written even d beta over dt, okay? You can have differential equations which are written as d phi over dz. So it all depends. You can have differential equations which are written as this way, of dw, something like that. But all in all, you have to know that this small d is usually common, isn't it? And when this small d is usually common, it is very weird for you to come and write for me a differential equation that looks like this. That simply because you want to maintain a convention of the first letter that distance is d, so you tell me this is dd over dt. Oh, it doesn't look proper, does it? So it's always good now that we use, you can write that differential equation, say dy over dx, and this is the most common one, and then dy over dx, and then you can come and tell me that y represents distance, and then x represents time. So I shall know then dy over dx will be speed. That's what I know. Okay, so now this is a differential equation. Okay, this is a differential equation, and it's not an equation. So you see, like for people who are strict, they might say, oh no, that's not an equation, where's the equal sign and all that. Yes, it's not an equation, but what it means, differential equation, is that you can have let's say a differential equation, of course, must have an equal sign, and it must be in the form of dx over dy is equals to, over, sorry, this should be x, should be, let's say, 3x plus 5x. So that's a differential equation. So an equation must have an equal sign. But here, I was just telling you the meaning of, I was just trying to explain to you what this part really means, okay? So that part means nothing but a rate of change, okay? One quantity changing with respect to another. And when you see this, it means that quantity y here is changing with respect to quantity x. Okay, yes. So now I shall give you people an example, and then you can tell me what this means. So given, so I'll first write the first example here, and you can try to think about this. I'll give you 5 seconds, and then you can pause the video, and then you see what exactly that means. So now so given two quantities, x and y, where x represents distance and y represents time, explain the following. So explain the following. So I'm writing big ones, that's why. So number one, dy over dx, 2 dx over dy. So 5 seconds, and let's see what you guys are going to think about, and then you can see, based on, you can compare my answers. Okay, thank you. So the first one, okay. Now, since now you are told that our question tells us that quantity x, you are told quantity x is distance and quantity y is time, isn't it? So when quantity x is distance, that means that this first one, it is time changing. Time is changing with respect to distance, isn't it? So time is changing with respect to distance, isn't it? So when time is changing with respect to distance, this means that this is nothing but an inverse speed, isn't it? This is an inverse speed in the sense that the units now will be hours, will be given in form of hours per kilometer instead of kilometers per hour. So the first one is an inverse speed, okay? Then the second one, now, because based on what you are told, isn't it? So the second one will be distance changing over time. changing with respect to time. So this will be speed, isn't it? So this will be speed, and the unit now will be kilometers per hour. So did you get that? So I really hope that you got it, okay? I really hope that you got it, because it's not one that is complicated. Okay. So I will have another one. Let me see if I can have another example. Let's see if I can have another example for you guys. Okay, so another example is now I'll just have to draw a Jacob. So no, I will have Kipchoge, because you see we are from Kenya, and so Kipchoge, this is Eliud Kipchoge. I know him. It's my friend. So Eliud Kipchoge starts this marathon at 9 p.m. Okay, at 9 p.m. and then finishes. He covers 80 kilometers. He covers this distance is 80 kilometers, the one that he runs, and he finishes at 9:58 p.m. So what is the rate of change? The question is what? The question is what? Maybe I can reduce that pen size. What is the rate of change of Kipchoge's time with respect to distance? Okay, so okay, you can try to do that. So 5 seconds. 5, 4, 3, 2, 1. Okay, thank you. Let's continue. So have you gotten the solution? So let's come to the solution. Okay. Now I think I'll just have to use a different pen. So solution. So what is our solution? So you're told that the distance. So first of all, I'll just use symbols. Okay. So I told Kipchoge's time with respect to distance. So I'll say let x be time. Okay. And then let y be distance. Okay. So now we want the what is the rate of change of Kipchoge's time with respect to distance. So that means we are taking time, so delta x over delta y, isn't it? Which this is nothing but this dx over dy, okay, which is nothing but time. You are told it's 9:48, so this is how many minutes? This is 58 minutes, isn't it? So 58 minutes into an hour, it's nothing but 58 over 60, isn't it? Over the distance, which is 80 kilometers. So 80 kilometers. Okay, sorry, it's disturbing me. So it's 80 kilometers. So what is the solution? So I will go back again to one of my calculators. So it's going to be, so I can have that on here. So I'll have it 58 over 60 divided by 8. Okay, so this is nothing but, so my solution here will be, yes, let me just come back, 0.012. So 0.012 then hours per kilometer. So the drill, the thing here is just to follow instructions. I mean, you're not supposed to answer a question that you're not told. So, and make sure that units, or rather the symbols, are consistent, okay? If you're using hours, of course, you expect you to use kilometers and something like that and so forth, depending on where you are anyway. There's some countries that are using miles depending on what system you are using. But for us, this is what we're using. So another thing that I'll say is that, so basically, this is the introductory part of that differential equation, okay? So the thing is, we have seen, the thing is that we have seen that at the moment we are considering one quantity, so one quantity varying with respect to another quantity, okay, with respect to another quantity. So when one quantity varies with respect to another quantity, when we see how, or the rate of change of one quantity to different another quantity, now that is what we talk about differentiation. So that's what exactly differentiation is. So differentiation, you might go look for definitions, I don't know what, but this is the most basic thing that you need to understand about differentiation. It deals with quantity y varying with respect to x, or quantity x varying with respect to quantity y. In other cases, like for this one now, this is the basic calculus. So this is calculus 1. So of course, we can look quantity 1, that one varying that way. And then in some higher calculus, as I said, we can look for several quantities varying with respect to one quantity, or varying with respect to another quantity, something like that. So for instance, like the one that I said, you can have quantity x and quantity y, all of them varying with respect to quantity z. So you shall have something like that. Okay, so this means that quantity x is varying with respect to z, and then this one is also varying with quantity z. Okay, so when you write this one, you can write this one as dx dy over dz dz. But you see, there's no point of you repeating this, isn't it? So what you usually do, you usually write this one in this form, dx dy, and then dz you square it. And then also you can have a certain quantity. So let's say quantity x, quantity y, varying with respect to quantity z and quantity b, isn't it? So in this case, this one can only be written as dx dy dz db, isn't it? Yes. So what it means is that whichever way that you're going to have it, I mean, this is nothing but a construction. So when you see like these quantities, all of them are varying with different with the same quantity, you can construct it, you can contract it, okay? So contraction, like for example, if you have quantity x, quantity y, quantity z, all of them varying with respect to quantity b, quantity b, quantity b. So you can have this as delta x dy dz, isn't it? All of them d cubed b. Okay, yes. So this is what I'm talking about. So Basically, that is what we are having. So we can have these constructions if and only if they're similar. Okay, and then we can also have another situation. Let me just take you up so that you can see. We can also have another situation. You can have a situation whereby you have a quantity x varying with respect to y, and then this one again, you vary it again, the same quantity. Now you vary it again with respect to y. Okay, so now this you can write it as dx dy, and then this one is also varying again with respect to dx dy. Okay, and this you can contract this into delta x okay, you can contract this into d squared x into d squared y, isn't it? But when it comes to writing, we don't. Okay, I will show you the conventions that we use. Okay, in this situation, what we do, you write it this way. Let me see. So you write it d squared x over d. I will tell you why. Okay, later on, I shall tell you how those things change or rather vary. Okay, so now for this calculus that you're having, or you can check it out. For this calculus that you're having, or why should you waste time? Let me just show you something. So second order differential. I'm seeing some here that is written. Yeah, so you see like this one here. You can see how it's written. D squared y over then this power comes somewhere there, isn't it? So this is the format. This is the right format. Okay? This is the right format. But I shall tell you. So this one can also be written as, this one here can also be written as d dy and then dx over dy. Means that you are differentiating that one again with respect. It means that you're differentiating dx again with respect to what? To y. So the one that usually has just one, or rather, let me just show you something here. The one that is just written this way, dy over dx, this is usually a first order differential equation, first order. Okay, then the one that is written as d squared y over dx squared, this is a second order. Okay, this is a second order. So I really hope you've gotten to know these first basic ones, and I think from here, now that you know this one, but don't worry, we shall revisit what is the order of a differential equation, what is differentiation. But I hope you've just known what differentiation means. So differentiation means that one quantity is changing. So this is my motor that I drew, or a machine or a generator. Like, okay, let me just draw a generator here. So this is a generator. So for this generator, fuel is decreasing as time goes by, isn't it? Fuel is decreasing as time goes by. Its temperature is also increasing as time goes by because it's running, isn't it? So basically, when you want to look one quantity, how one quantity varies with respect to another, then we employ, that is what is known as differentiation. So I hope you've understood something when it comes to this calculus 1 and this video, and Have a nice time. Please don't forget to subscribe, and let's continue to the next series of videos for calculus 1 and differentiation. Thank you.